I hope if you don't understand what I'm saying, just ask, please. Do you understand what I mean by fragmentation? You know, sometimes Windows will say defrag.
Yeah.
Yes. Because of the way the file system is arranged, they are arranged in small pockets. But in Linux, it's not like that. So you don't have fragmentation issues. That's why Professor Ture was saying it's very hard for a Linux machine to crash. Very, very hard. But it can easily crash if you don't know what you're doing. Right. Okay. So let's move on. Okay. Right. Very good. The next thing we are going to look at is installation. It's unfortunate all of you don't have internet. Linux revolutionizes installation. Let me start from Windows. For instance, I want to install AutoCAD, right, on my machine in Windows. And I start installing, maybe it's 10 gig worth of file. These days we have games that are 40 gig big. And I start installing and I go maybe 50% done. You can never stop the installation. Do you agree with me? You can't break the installation and then continue again. You can't do that. If you break, you have to start from the beginning. But in Linux, you can start from anywhere in the installation and break at any time. So, for instance, you are installing something that is 15 gig. Let me try to install something on my machine. Yes. So, I already have it installed. Let me remove it. So now if I want to install something like this, right? You see it's downloading, right? And it's trying to install. I can now break it halfway. Right. Yes. Yes. So operation was interrupted before it could finish, right? So I've stopped my installation halfway, but I can continue at any time again. So, right. It's done. This is the OP one. Right. This is your pillar. So what does that mean? What that means is that as an engineer, you are very busy. Most engineers are very busy, right? And you want to do something in between. And you've gotten something started, like 10% started, and it's so large, 10%, right? And maybe 50 gig or something. You can stop that process, then do what you need to do quickly, then go back. Right? It's very convenient. But don't try to me. Yes. It's very convenient. So I have control over how things are getting installed on my machine. Right? Unlike Windows where you just have to wait for the machine to complete. Another very powerful thing in Linux is that you can do something like this. Yes. Control C. Yes. So I don't know what that means, but I really don't know the meaning of Control C, but it's like it has come to stay. To continue. Oh yeah. Sudo apt. I have aliases. Forgive me. I have aliases, but you will come to that shortcuts. To install a Linux, you need to do sudo. Let me do it on. Please type with me, but you may not get internet access. So sudo means super user do. apt, then get install. Then the name of what you need to install. Right. So install Okida. But like Professor Damon said, in Linux you must To be an effective engineer, one secret of being a very effective engineer, you must hate repeating things. You must have zero tolerance for repetition. Every time you have to do the same thing over and over and over and over again, you must not like that. So in Windows, in Linux, this is a very long command for me to type. I don't like typing this thing all the time because I do a lot of installation. So I summarize this as I, standing for install. So once I say I, it copies this, then accepts the next parameter. Do you get it? And so that's why, since it's my machine, I said I, this. Right. Now, that takes me to the next point. Now, in Linux, I keep saying in Linux because I want you to soak down that you are becoming a Linux convert. Right? Okay. So, this is what I have. Let me just show you something. I have good. I have a list of commands that I keep updating, or list of programs that I keep updating all the time. Right? So maybe I've made a fresh installation in on my machine. I have this file that keeps all the commonly used programs that I need. I just have their names like that. So you can see Vim here, or you can see the Okila I just installed, GNU Radio, all these things like VLC and the rest. You can write all of them in one file. It can be a million. Linux doesn't really care, right? It can be a million of this. And then you can do something like you can install all of them at once. Right. Right. It is now going online and installing every single one of those files that I have on my machine. You see, it's fetching them from the internet and installing them one by one by one. So sometimes I don't even remember some of them. I just know that when I need it, I'll get it. And like I said, right, sorry, it's already there. So like I said, I could stop this at any time and then continue with what I was doing. So that is what we have: bulk install and partial install in Linux. Yes. Yes, we'll come to that. We'll come to that. Yes.
So is there any program maybe install?
Yes, there's a difference because, like I said, the difference in Linux, what makes Linux secure is the password. So a super user simply means someone who has administrative rights. I hope you understand what I mean. Yes, you can administer the machine. You know, the topic we are dealing on is what? Systems administration. So if you have administrative rights, that means you have right to install, you have right to uninstall, you have right to change settings and all that. So you have to do, if you're not a root user or a super user, then your prompt will have a $sign. But if you are a root user, your prompt will have a $sign. So this tells you where you are. This tells you that you are in your home directory and you are not a super user. So if you want to install this as a super user, you say super user do. That's sudo. Then you give the instruction. So it will give you a temporary administrative privilege. So you can install or do whatever you want to do. I hope that's clear. Thank you. Please, I hope you are following. Yes. Are we following? Right, thank you. Now using this. Okay. The next thing is as a systems administrator, is that you want to monitor processes. And a process in Linux is just an instance of an application. So if I'm running VLC, I'm running a VLC process. So if I want to see, just like in Windows, you have Task Manager, right? How many knows about Task Manager?
Yeah.
Right. So you want to see the processes that are running on your machine. You can do PS. Let's do that. PS. Then AUX. Then hit enter. Now I'm going to use this to explain two things, two very important things. Linux is designed based on what we call the microkernel paradigm. Microkernel. So the kernels are built in blocks. Everything is not given to you at once. I mean, you can install a full Linux operating system for just 500 megabytes. On just 500 megabytes of space. Right? A whole Linux kernel on just 500 megabytes of space. Because you have the opportunity to remove things that you don't want. Unlike Windows, once you install, you have no choice of installing. There are people who install Ubuntu without a desktop. They don't use desktop. All you just see is just a terminal. Once you put it on, for instance, you go to maybe Cisco networking. Once you just put on the machine, you don't see desktops, you don't see icons and those things. All you just see is a command line prompt. Because he doesn't like using a desktop, he wants to just use command line prompt. Somebody may want to move speakers, he doesn't need a speaker. So, because you can plug in things and remove them at random, you can alter the size. Right? So, in installations that may need 10 gig, you can bring them to 500 megabytes.
Have you been typing it honestly?
Right. So what that means is that programs can be built at random. Right. So for instance, Task Manager, you cannot block Task Manager to anything. You cannot use Task Manager anywhere else. Task Manager is just what? Task Manager. But in Linux, Task Manager is not just Task Manager. Task Manager is a tool. Right. So since it's a tool, it means that you can, what we call pipeline. Right. Pipeline it with another tool. So in this case, as you see, when you type that command, what happened? You saw a long list of things, right? A very long list of things. Now, you now have to think, so what do I need? I need to be reviewing them frame by frame, right? Frame by frame. So that brings us to that point that I talked about the files. Hence, the standard error, the standard in, and then the standard out. Right. With pipelines, you can change the directions of these things. So, PS is an application, right? It produces what? An output, right? And requires an input. So what that means is that I can take the output of this thing and give it to another program. Do you understand? So if I take the output of PS, instead of it just appearing on my screen, I can decide to give it to another program. And in this case, we are going to give it to another program that will slow things down. Okay. So when we say PS, it doesn't just go straight to standard output. It will go to that program, then that program will manage things before it comes to the output. So let's do this is going to be pipeline. So let's do PS AUX, then pipeline. This symbol. Yes. Pipeline, then less. What this means is that the output of PS, that is the standard out of PS, no longer comes straight to the screen. It goes to the input of less. So I have now changed the direction of my program. Right, so standard outputs of PS goes into what? Standard inputs of less. Do you get it? Right.
No.
Okay. Please, I told you in Linux everything is very important. So PS, one space, small a, small u, small x, one space, this symbol, one space, less. Right. Okay. Yes, that's what. Yeah. So please, have you done that? Yes. Right. When you do that, let's see what happens. Now you see, it's now slow system. So this is the heading, right? So you see user P, process ID, CPU, directory, V, XZ, and the rest. And then you see this column down here. You have to see this column down here. So that bulk of data, this is the first chunk of the data. Then press space bar. Space bar, you see to scroll, right? So now you have control over the display, right? You now have control over the display. Then if you hit it, it keeps moving down till you move to the end. So this functionality of taking things slowly is not built in what? PS. PS doesn't know that you are actually doing this. PS has done its work and given you an answer and has gone on. Now you now take that answer, you don't want to put it straight to the screen. You now have to do something else with it. And in engineering, what do you deal with the most is data. Right? You deal with a lot of data. So you have to find a way to manage your data correctly. Right? Let's make it more fanciful. Press Q, the letter Q. Now, in between the less and this, let's do something like this. This way.
Skipping each other. Each other. I do see that now, which I'm so long.
Because USB does not charge. Like USB to computer does not charge very fast.
Right. Good. So this screen is a bit big. Now I have added a new command. You see, the first command we wrote, that is this one. Let me remove this. You see, it doesn't have numbering. There is no way I can know where I am. So when I start moving, I don't know the line I am in. Right? So that means now, if it's in Windows, there is nothing you can do about this. You have to wait for the newest version that will include numbering, right? You have to wait for an upgrade or something. But the building block style in Linux, you can add something, a program that can be numbering lines for you. Right. So let's write this command. So I am saying, take the output of PS, send it to this program, and this program will add number lines to it. Send it to this program, and it will make me view it step by step by step. Right. So now you see number lines. Number 1, number 2, number 3, number 4, number 5, number 6. Yeah. You see. So I am building now. You see, it's now like a building block. Are you following? It's not like a building block. So you can build and build. And I can add this straight. If we had a printer here, I'll just add another line. I'll pipeline it again and say